Hola amigos, it's me, Manny. Today, we've got a really interesting project to work on. We're going to help an engineer who needs to understand something called shear and moment diagrams. Have you heard of those? Well, don't worry if you haven't. We're going to figure it out together. Are you ready?
Yeah, let's go!
Great! Let's head to the workshop and get started. Okay everyone, we've got a beam here. This long, strong piece of material that helps hold up buildings, bridges, and even houses. But there's more to this beam than meets the eye. When a beam has weight or loads placed on top of it, it has to deal with two important forces: shear and bending moments. And guess what? We need to make diagrams to help understand them. Who's with me?
I love diagrams. They help us see what's going on inside the beam, right?
Exactly, AJ. Diagrams helps give us clues about what's happening inside the beam. Let's start with the first one. Shear force. Now, shear forces are like invisible hands trying to cut or slice the beam apart. It's like when you try to tear a piece of paper. Part of the beam wants to slide one way, and the other part wants to slide the other way. But we don't want it to break now, do we?
No way!
Right. So to figure out how much shear is in the beam, we use something called a shear force diagram. Let's draw it together. Here's a simple beam. Now, let's say this beam is resting on two supports. These supports help hold the beam up.
Hold up, Manny. What happens if we put something heavy on top of the beam, like a big box?
Good question, EA. Let's say we put a heavy box right here in the middle of the beam. When we do that, the beam feels pressure at its ends. The supports push up and the load pushes down. This creates shear forces at both ends of the beam. See? These arrows show the shear forces, the parts of the beam that feel like they're being sliced or cut by the load. And when we make a shear force diagram, it often looks like a triangle or rectangle, depending on where the load is. Look, this is the shear force diagram for our beam. The forces are the strongest at the supports, and in the middle, they're smaller. This diagram helps engineers know where the beam is most likely to feel the pressure of shear forces. Got it?
I get it. So the diagram tells us where the beam is being pushed or pulled?
Exactly, Eljay. Now, that's only part of the story. The beam isn't just feeling shear forces, it's also bending. And that's where the bending moment comes in.
Oh, bending moments. Does that mean the beam is twisting like a pretzel?
Not quite, AJ. When we talk about bending moments, we're talking about how much the beam is bending or turning because of the load. Imagine bending a ruler. On one side, it stretches, and the other side gets squished. That's what happens to a beam when there's load on it. To understand how much the beam is bending, we draw a bending moment diagram. Let's draw one now. Here it is. This curve shows the bending moment. Notice how it's highest right here in the middle, where the load is. That's where the beam bends the most.
Whoa! So the beam bends in the middle, and the supports help it stay strong?
Exactly, Pat. The supports help keep the beam from collapsing, and the moment diagram tells us how much the beam is bending. The bigger the curve, the more bending there is. Now, we've learned about both the shear force diagram and the bending moment diagram. Let's put them together. The shear force diagram shows where the beam is being pushed or pulled, and the moment diagram shows where it's bending the most. Together, these diagrams help engineers design strong structures that won't break or bend too much.
So, shear forces try to cut the beam, and bending moments try to bend it. And the diagrams show us where that happens?
Exactly, EA. Engineers use these diagrams to figure out where the beam needs to be the strongest. That way, they can design safe buildings, bridges, and other structures. Let's look at an example. Imagine we're building a bridge. Let me show you. Imagine we're building a bridge. If we place heavy cars on the bridge, the beams holding it up will feel the shear forces at the ends and bending moments at the middle. The engineers would use shear and moment diagrams to see where the beams are under the most pressure. Then, they'd make sure the beams are strong enough to hold up all that weight without breaking or bending too much.
That's so cool! So, shear and moment diagrams help us build strong bridges and buildings?
Exactly, Eljay. They're like a blueprint that shows us how the forces are acting inside the beam. Without these diagrams, we wouldn't know where the beams need extra support. Now, let's do a quick review to make sure we've got it all right. Who remembers what shear forces do?
They try to cut the beam. They push or pull at the supports.
Great job! And what do bending moments do?
They bend the beam in the middle. They make it twist or turn.
That's exactly right. And what do shear and moment diagrams show us?
They show us where the forces are strongest.
Exactly, Pat. The shear diagram shows us where the beam feels the most pressure from cutting forces, and the moment diagram shows us where it's bending the most. Together, they help engineers build safe, strong structures. Muy bien, amigos! You've learned all about shear forces, bending moments, and the diagrams that help us understand them. You're practically engineers now.
Does that mean we can help build a real bridge next time?
Maybe someday, AJ. But for now, we've done a great job solving the mystery of shear and moment diagrams. Thanks for your help today, guys.
Woohoo!